Question on elasticity is ready. Yes, the first calculation we are going to do. So let's do it together without taking time. Once you know the possible expressions or equations that you need to solve problem, you don't have problem. Then you can think both inside the box and outside the box. Solving problems become easy. So let's look at this. Example 1. If a force of 50 newtons stretches a wire from 20.00 meters to 20.01 meters, what is the amount of force required to stretch the same material from 20.00 meters to 20.05 meters? And we are given these options. This question is actually from 2004 UTME, that's JAM. Question number 35. Okay, so let's solve together our solution. Now, whenever I want to solve a problem, I usually apply what I call the I-see principle. If you can see, you can solve problem in physics. I means to identify. This means to set up. These two will always go together. When you are given a problem, identify the quantities in that problem, then set it up using the appropriate symbol. So if I identify this, what is the symbol for this? That's the setup. Yes, that's how to set up. In some other cases, you can still set up. In setting up question, we may need to put up diagram to explain the question further. It's still part of the word setup, but not in all questions. Like in this question, we don't need a diagram. Okay, so let's identify, and as we're identifying, we are going to set up. So if a force of 50 newtons stretches a wire from 20.00 meters to 20.01 meters, what is the amount of force required to stretch the same materials from 20.00 meters to 20.05 meters? So if a force of what? 50 newton. So that means the first quantity there, a force of 50 newton. Now somebody will ask immediately, how do I know I will put F1? In the course of reading the question, I saw another force. So that means I need to distinguish these two forces. And that's why when we derive the equations, we have F1 and F2 in one of the equations. I hope that is clear. So a force of this stretches a wire from here to here. That means originally this is the length of the wire. But when a force of 50 newton was applied, it now produced this new length. So we had an original length L0, 20.00 meters, and then giving us a new length of 20.01 meters. Okay? If you have watched our videos, then you will understand other videos that explain the equations, basic equations we use in Hooke's law. Okay. Now they say what is the amount of force required to stretch the same material from what? From this to this. Okay. What force is required? So we are looking for the second force that will produce a new length. Remember, this is still the original length. This 50 move this original length to this, so original length to new length. Now, which force will move it from its original length to what? To 20.05. We are not going to write this again because it's the original length. So L2 now is 20.05 meters. Okay, so what force will do that? Now, the same material. You remember that we say that force constant is constant if the materials remain what? The same. So K1 is equal to K2. And when we say that, it helps us to generate more equations that can help us in solving problems involving Hooke's law. Yes, we saw that together. So let's look at this. What are the equations in Hooke's law? We have that force is equal to Ke. You remember that? If you add another Ke, it becomes Kk, but we are not here to write Kk, so force is just what? Ke, not Kk. Then we also say that E1 is L1 minus L0, that E2 is L2 minus L0. We establish also that F1 over E1 is equal to what? F2 over E2. And then we also say that F1 over L1 minus L0 is equal to F2 over what? L2 minus L0. About 5 equations that we generated in our previous video. Yes, videos. Yeah, for solving problems in Hooke's law. So if you notice, this whole of these 3 will not be relevant for us because we don't have F2. If we are going to use them, it's not to find F2 directly. It may be to find another quantity that we will use to find F2. But let's see where F2 appeared. We have F2 here. We know F1, but we don't know E2 and E1 directly. They were not given as part of the parameters directly. Not that they cannot be found, but they were not given. Okay? So when we check the other one and we discover that we still have a problem, then we can see if we can use this equation. But for now, this cannot give us F2 directly. Not that we cannot use it, but directly, because we don't know this and this. Then we'll go to this equation. I'm looking for F2. It means I'm supposed to know every other thing apart from F2. You know, that's why I did not use it here. I'm looking for F2, but I don't know E1 and the word E2 directly. They were not given. So that's why I suspended this one. I said, wait, I can't use you to solve my problem. So I'll move to this one. I'm looking for F2. For me to use this equation to find F2, I must know every other parameter, every other quantity here. Do I know F1? Yes, I know. Do I know L1? Yes, I know. Do I know L0? Yes, I know. Do I know L2? Yes, I know. So the only unknown is F2, so this expression is suitable. But you know, if you want to use this, it means that you need to find E1 and E2. That means you will come back here, use L1 and L0 to find E1, bring it here. Use L2 minus L0 to find E2, bring it here. So that the only unknown will be this. But remember, we have to save what? Time. Yes, we have to save time. We have to save time. We have to save time. We have to conserve time in ourselves. So what are we going to use? F1 over L1 minus L0 equals what? F2 over L2 minus L0. What is my F1? 50 divided by 20.01 minus 20.00. That's L1 minus L0 is equal to F2. I'm looking for you. 20.05 minus 20.00. Okay, this will give me 50 divided by this minus this will give me 0.01 equals F2 divided by what? 0.05. Okay, so what do? We clear the fraction. If you are good at using handling decimals, you can actually eliminate this and move away. If I'm the one solving, I can remove these 2 decimals since it's the same here. Now I'll have 1 and 5. Yeah. So one of these days we are going to treat how to solve problems involving decimals and powers of 10, so that you see how you can handle that easily without having problems. But let's multiply. We have 0.015 1F2 equals 0.05 times 50. So this will give me 0.01 F2. This times this will give me 2.5. So how do I get my... Okay, I think I have a space here that I can use. Okay, let me use that space. Yes. So what is F2? Make F2 the subject of formula. F2 becomes what? 2.5 over 0.01. That's by dividing both sides into what? By dividing both sides using what? 0.01. So F2 will give us this, divide this and move this. We have 250 Newton. Now, if you are good at mathematics and you have an understanding of what the law is, the moment I see that 50 only produce extra 0.01, it means another 50 will produce 0.02. It means another 50 will produce 0.03. Another 50 will produce 0.04. And the next 50 is 0.05. That means how many 50s now? 5 50s. And 5 times 50 is going to give me 250 Newton. That's our answer. But you need to have an understanding of that law. So in most cases, the examiner is not expecting us. This UTME. In UTME, you have about 40 seconds to answer your question. Now, an examiner is not expecting you to do all of this. The examiner is thinking, is checking whether a student can actually understand that this 50 Newton did this, whether you can see this and this, and know that this is just 5 times. And it's 250. But by the time you solve problem more and more, you begin to master this. Thank you for watching our video. Remember, we just solved question number 1. We have many more examples to actually solve. Thank you, and God bless you.